Class 12 Maths NCERT textbook question. It is your question number 9. In this question it is asked, f is a function from set of non-negative real numbers to codomain is negative 5 comma infinity. That's a semi-closed interval. And function fx is given as quadratic polynomial, which is actually 9x square plus 6x minus 5. You have to show that f is invertible. So for that, what to show? You try to show f is 1 1 as well as 1 2. So at first let us try to show f is 1 1. So in order to show 1 1, what to do? Simple. Declare fx1 equal to fx2 for any x1 x2 belongs to the domain of the function, that is r plus in this case. Then functional formula given, it is your 9x1 squared plus 6x1 minus 5, which is equal to 9x2 squared plus 6x2 minus 5. Now rest of the part is simplification. From here you have to show x1 equal to x2. So for that these two cancelled out. Now what do you get? You see 9x2 squared, let me take common 9, you will get x1 squared minus x2 squared, taking this in the left hand side, plus 6x1, 6 common, what you will get? x1, it will be minus x2 equal to 0. Then you see, it is your what? A square minus b square, so a minus b into a plus b. So directly you can say x1 minus x2, this factor is common. What is left here? x1 plus x2, multiply 9, then it will be 9x1, 9x2. And here plus 6, which is equal to 0. Now simple reasoning, x1, x2 non-negative real numbers. x1, x2 are not negative. That's why 9x1 plus 9x2 plus 6, it cannot be 0, because all are non-negative. Sum of non-negative numbers cannot be 0. If x1, x2 become 0, then also plus 6 will be there. So from here what you can say, x1 minus x2 is equal to 0 as 9x1 plus 9x2 plus 6 is unequal to 0. Then finally you obtain x1 equal to x2. So you obtain x1 equal to x2. So whenever fx1 equal to fx2, then we can show x1 equal to x2. So from here you can say, so f is 1 1. F is 1 1. Or you can say f is injective. So next, what is left? Next you have to show that f is onto. Then f will be bijective and then f inverse exists. Okay, now let us try to show f is onto. Here only I will show. So in order to prove some function is onto, what to do? Say we have to show f is onto. যেতিয়াই function এটা onto দেখুৱাব লাগে, in that case what to do? Consider any element in the codomain. Say any element y belongs to codomain, and for some x, suppose fx equals to y. Then try to show that x belongs to the domain of the function. Then it becomes your onto. Say let any y belongs to codomain. Here codomain is your semi-closed interval negative 5 comma infinity. And you declare fx equals to y for some x. Some students, what they do, for some x belongs to domain coordinate. If you say for some x belongs to domain, then there is nothing to show. So simply you say for some x. We don't know whether this x belongs to the domain or not. Now we will try to show that x belongs to the domain. For that, you observe the nature of the domain, set of non-negative real numbers. If you can show x is a non-negative real number, then it is done. X belongs to the domain. Then that part how to show? For that, write the functional formula as it is. 9x squared plus 6x minus 5 is equal to y. Now the most important point or the part comes here. So for that how to do, I will explain it in detail. So now in order to show it's onto, so we considered y in the codomain and fx equals to y for some x we assumed. Then fx means your 9x square plus 6x minus 5 equal, and which is equal to y. Now in this case you have to consider it like this way: 9x square plus 6x minus it will be 5 plus y equal to 0 if you transpose y to the left side. You consider this as a quadratic equation in x and y as a constant. I repeat, here you have to consider this as a quadratic equation to find the value of x. As I told, in order to show some function is onto, consider fx equals to y for some x and where y any element in the codomain, then try to find out the value of x in terms of y. But in this case, how to find the value of x in terms of y? For that, you have to consider this as a quadratic equation, considering y as a number or constant. So if you compare this, then it is ax square. A means what? 9. B is your 6 and C is your minus of 5 plus y. Now we are going to use quadratic formula to find out this. Now let us use the quadratic formula here. So using quadratic formula, x is equals to minus b, b is your minus 6, plus minus under root over b square, that means 6 square, that is your 36, minus 4 times a into c. So if you take 4 times a means 4 into 9, 36, and already it is minus, that will be plus 36 times 5 plus y. 5 plus y. Divided by twice a, that is your 18. Now you see, 36 take out, then here 6 will come, and if you take 6 common, let me write directly, carry 6, then it here, let me minus 1, plus minus under root over 1 plus 5 plus y, divided by, if you cancel out by 6, that will be 3. I repeat, 36 is here, take out, 6 will come here, 6 common, 6 3s are 18 to 3, and here minus 1 plus minus root over 36, so common you have taken to 1 and 36 out, that is your 5 plus y. Then you see what you get, minus 1 plus minus under root over 5 plus 1, 6 plus y divided by 3. So finally we obtain your x is equals to this much. Now remember, while you are calculating the value of x, always consider the positive value. Minus 1 minus, don't consider this, x equals to minus 1 plus root over 6 plus y divided by 3. Because in the function you will see the domain is a set of non-negative real numbers. So if you consider minus 1 minus, that is your negative, that value does not belong to the domain. There is a chance that whether this belongs to the domain or not. So we have considered this, and it is nothing but under root over 6 plus y. 6 plus y minus 1 divided by 3. then this value whether greater than 0 or not we have to check. For that, let us see the value of y. And y is any element in the codomain. What was the codomain of the function? You check it. Codomain of the function is your, we considered y in -5 to infinity. As y belongs to -5 to infinity, that is y is always greater or equal -5. So adding, now see, adding 5 in both sides, y plus 5 is greater or equal 0. Here it is what? Y plus 6 or 6 plus y. Then it will be adding 1 in both sides. Y plus 6 greater or equal 1. You can say 6 plus y greater or equal 1. As 6 plus y greater or equal 1, then definitely 6 plus y is a positive number greater than 0. Now come here. As 6 plus y, or here only you can see. Look at this. So here we obtain 6 plus y greater or equal 1. That means root over 6 plus y is your greater or equal root over 1. That is positive value we are considering. Square root of 1, 1. Now subtract 1 from both sides. Root over 6 plus y minus 1 greater or equal, from right side also subtract 1 is what? 0. Then from here what you can say, root over 6 plus y minus 1 divided by, divide both sides by 3. 3 positive number, so 3 there will be no effect. This is greater or equal 0. So you justified it that root over 6 plus y minus 1 by 3 greater or equal 0. And this is nothing but your x. So finally x is greater or equal 0. As x is greater or equal 0, so x is what? Non-negative real numbers. So you can say x belongs to set of non-negative real numbers. So x belongs to set of non-negative real numbers. What we have proved? That for any element y in the codomain, there exists some x in the domain for which fx equals to y. It means f is your onto. So finally we proved it that x is a, f is a onto function. So f is onto. Already we proved f is 1, 1. So that means f is bijective. As f is bijective, it means f is invertible. Invertible. So finally f is invertible. We proved f is invertible. Then in second part it is asked what's the inverse of the function f. So once you prove that f is invertible, it is very easy to write the inverse of the function. From where to write? It means when finally you calculated the value of x is equals to under root over this. So let me write here. Where you calculated x is equals to root over 6 plus y minus 1 divided by 3. Now what is the f inverse? F inverse will, because as you know y equals to fx. So from here what? F inverse of y is equals to x. So in place of x just write f inverse of y is equals to root over 6 plus y minus 1 divided by 3. This is your inverse of the function you proved. I hope it's clear to you. Thank you.